I need you all to understand before we make headway with this collections in general. First of all, I mentioned that collections give us the ability to group elements or group items into one particular entity or a bucket. Basically, a collection of items considered as one, and those items must be of the same type. And I showed you guys how to create collections by by we did array list the last time, and to do that, you saw how to do that, and you saw where you specify the type of items is going to be accepting basically, and all of them have to be of the same type. So some loose languages like Python or JavaScript have the possibility of you passing different objects of different types into one collection. And what I mean by that is that you can have string and number and double or float or boolean into one collection of lists. What that means is that we can have a list of, let's say string, let's say uh, Stanley, which is a name, and we can have two, which is a number, and then we can have true, which is of boolean type, and we can also have car, car. So JavaScript and Python and a couple other languages, they have the ability to do this kind of thing. But in Java, you don't do such thing basically. They take the same element of the same type. If it is string, it has to be of the same type. If it is a number, it has to collect only numbers. So that's a quick recap on collection. And so, okay, this is the thing I need you all to understand henceforth. For most of your experience in programming, you see instances where let me type in my PSVM. Okay, you see something like what we treated last time was something like this array list. Let's say it takes an integer, and I'll call this R. Let's then new array list. I will import. Okay, it has imported. So this is what you guys are used to. Now, when you get online or when you start exploring, most of the time what you see instead is something like this. Let's say this one is taken in string, not let's say this one is str equal to new array list. I would import my list and this thing. Most of the time, this is what you see. If you look here, what you're seeing here, array list is the same with what's on here. And what's on here is the same with what's on this side. I mean, what's on here is different with what's on this side. And there's a reason for that, and that's because array list, if I go to array list, if I hold command and click that array list, it will take you to the documentation, basically. It will take you to documentation of array list. Where is the beginning? Okay, these are the import statements. Where is it? What am I looking for? Okay, since you can't see that, what I could do is to okay, let me demo it for you guys. I'm going back to let's go back to the basics of OOP now. Let's go back to the basic of OOP. I don't know if this is necessary. I don't want to extend it. I don't want to drag it. But basically, okay, let's just brush over that. Let's brush over that. Let's say, for example, I have an interface. Let's call it interface 1. I'll call it interface 1. Okay, and then I have a class. Okay, let me still use this my collection 2, and then I say it implements interface. Okay, capital I interface 1. Okay. I'm coming. I need to confirm something first. New. Okay, yeah. Okay, yeah, that was it. Okay, I needed to confirm, I needed to be sure of something. So basically, if you have this kind of interface called interface 1, I call this interface 1. And remember how interface works. It takes in only methods and it takes in methods that do not have buttons, basically. And now this interface 1, this it has no body. You can give it sorry, it has no methods. You can give it a method if you like, but that's not the point I want to drive to now. And if you come to this class collections 2, it's implementing interface 1. It's implementing interface 1. I'm trying to explain to you why this thing is like this. Why we have list, and then on this other side we have array list. And here we have array list, and this other side we have array list as well. These two things will work fine. These two lines, they will perform the same way. Now, I'm demonstrating it with this example I am doing now. We have interface 1, and then inside of this collection, remember if you do an interface, for it to make use of it, you have to implement it in a class. And let's say, for instance, I'm implementing my interface in this class, that's collections 2, and now I want to create an object using that interface, which is what I'm doing right now. Let me call this in. I can go, what's on this left side is allowed to be the interface. And now what's on this right side is the place where it was implemented, basically. And the place where I need it, the place where I implemented it is on this class, collections 2. So I can go ahead and say collections 2, and life is good. Now it's possible for me to say I implemented this interface also in this other class. Let's say it implements interface 1. Let me come here. Implement, okay. Now it's possible for me to come here and say, instead of, okay, let's say, let me come here first. I'll remove this thing. I'll remove this implement interface 1. I'll remove it first, and then inside of there, let me try to write collections 2, collections demo instead. I'll try to write it. You see it's complaining, and the reason is because this collections demo is not implementing that interface. But if I came here and implemented it and I go back, everything will be fine. So in essence, in a nutshell, all of what I've been saying is that by specifying the interface on the left side and then coming to the right side and specify the class which implements it, gives us the ability to change between classes on this right hand side. It's not the same if for a situation where the array where the type on the right side, which is this one, is the same for the type on the left hand side. So by doing it this way, that's having the interface on the left hand side and then having the class that implementing on the right hand side gives us the ability to switch between classes, because we know that those classes already implement this interface. So if I go ahead and change this thing back to collections 2, everything is still fine. What it simply means that the method which I defined inside of this class is what it will use now. Whatever method I specify inside of this class is what it's going to use. If I change this back to the other one, which was collections demo, it simply means that whatever method I specify inside of my collections demo is what's going to be used. So if, for example, I have another method, public void, let's say this one return. Okay, let's make it starting. And this one returns nothing. Let's say, I could call it sprint name. Let's say, for example, I have a method inside of this class called sprint name. Now, I know I've created my object specifying the interface I want to use and the variable name, basically. If I come here, and what the class I'm making use of now is collections demo, which I know is the other class, and I want to do something like if I want to make use of this object, in equal to print name, it will not see it basically because look at this class name collections name. If I come here, there is no such method as print name, but I know that has it has collections this thing. It's fine because I have that method created inside of here. Give it a second. Okay, I didn't create it inside of the interface. Okay, that's something I actually omitted. So I will create the listing of the public is unnecessary print name. Okay. Okay, that's fine. This is started. On implementation. Does anyone have any questions so far? I now see so many things I probably lost. Why is this complaint? Void. Is there any questions so far? Come on now, speak up.
I don't have a question.
The rest persons? Okay. This has to implement the interface. That's what it's complaining. I can remove this. The rest of you, any questions? Why is this still complaining? Friends name, Sorry? Voice, friends name, returns void. Bukola, do you have any question? Jennifer, and the rest of you.
Please, are you recording it?
I believe so. Let me confirm. Yeah, it's recorded.
Okay, thank you, sir.
Okay. Why is this complaining? Okay, default. Okay, okay. All right. I'll just put this here. Okay, so that's fine. Okay, that's just all I wanted us to know for now. It gives us the ability to switch between classes as we like. So on this side, I can decide to make use of collections too, and I can also, in the future, decide to make use of collections demo because I know they implement the same interface. What I'm saying is that henceforth, because you'll be seeing places where they're implemented like this, and just so you don't get confused, you could come tomorrow and this thing change to let's say linked list, which is another class that implements list interface. This list is an interface. You guys actually you, you know that you have the ability to go inside of these interfaces that have already been created. And to do that, if you're on Windows, you can use Home Control Click, and if you're on Mac, you use Command Click, and it will take you to where all of these things are defined. You can see that this list is an interface and it extends a class called collection. But you don't need to know up or to.
So please, you said if your Windows, you use what? I didn't hear
Control,
you. Sorry,
control,
sir.
then click. So you control click this and it will take you to where the code is. Did you hear?
Control what?
Control click, as per click. You hold control down, then click.
Okay.
Yeah. So all those methods you guys were doing in your assignment, you see they've been actually been created. It was created in the background. Like that one that you did size, this is it. That one some of you use empty, is empty, this is it. Some of you use contain, this is it. Some of you use which other one? Which other one? All these other ones we have to array. We have a couple other ones. We have add. This one's for adding to array list, or we have remove. You see they've already been created. So all these things are not magic. They've been created and documented. All these green text you're seeing is for you to consume them if you like. So So we've created and documented for it to go through them. We have contains or we have all the add all, we have remove all, and every other one basically. We have sort. So this sort in particular is why I'm introducing this thing to you. Sort is for to enable you to arrange in ascending order or descending order. We have clear, we have equal, and we have get, we have set, and a couple other ones. So I'll close this. Um, okay, let me go back to that place. Let me go back to that place. Okay, now you can see that this interface, the list interface, has been implemented in 283 places. It's been implemented in 283 places, different places. And some of the places where they were implemented, um, they've been listed here. That's set. Set is implementing this interface. Array, array list is implementing, linked list is implementing, vector is implementing. But most of these things, you do not need them now. So because all these places, they implement list, all those classes, they implement list. Let's go back to our picture. Where is it? Where is it? Let's go back to this big one. So this is that list we're talking about. So array list, linked list, vector, stack, all these things they are implementing interface. What implementing means is that I can actually go and change this thing from linked list to, let's say I want to change it to vector. I could change this to vector and everything is fine. Now I have to import my class. I import it and everything is fine. Which other one? Stack, blah blah blah. So everything can be interchanged. But if you change, if I change, if for example I change this to array list and then leave this one as vector, it will not it will not work. It will not work. So the restriction, this thing, you know, when you create an object, the way we've been doing before, for example, human, we have, if for example, you, what was one of the objects we created when we started? Let's say human. If, for example, we had something like human equal to new human. This is how you used to do it. Now I'm telling you that you can have a human implement an interface, and then on this left-hand side, you substitute, instead of putting that human, you substitute it with that interface you created. All right. So that's it for that. So back to this one. If I went ahead and put in the class, because this array list is a class. If you see it here, it's named as class. So by me using it as a class, it then means, where's my distance? It then means on this right hand side, I must tell it also that there's a class. I must use the same class. But to give us the flexibility of changing between different classes, we normally use interface on the left hand side. Say I want to change to which other one could I use? Which other one could I use? Okay, you already saw that. You already saw all of this in implemented. So I could use stack. Stack is another one. Another one that is implementing list. I believe so. Yeah, and everything is fine. I use array list, I use stack, I use linked list, I use vector. Because all of them here are coming from this guy here, the list. So on this other, and if you look, all of them are coming from this collection interface. This is another interface on its own. And if you look up, this is another interface now. So collection is implementing iterable. And list is implementing collection. Queue is implementing collection. Sort is implementing collection. There's a reason why Java code made it this way. And I'm coming to that. There's a reason why they were designed this way. So one of the reasons is to give us the ability to not repeat code to write them once in a place and basically use it up from there. If, for example, I have this, if for example I have this first line. Any question so far before I proceed? I'm not talking to myself. Any questions?
No,
Okay, that's
for me.
okay. The rest of you.
None for me, sir.
Okay. So if, for example, I have this is an array list of integers. I have 10, 9, 3, 19. And then I come here and say I have string. Sorry. I say hear me. I have let. Let's say I have let. So this should be commented. If, for example, I want to, I want to sort this first one. I'm assuming this is the list of these numbers now. I want to sort it to become this, to become 3, 10, and 17. And then this other one, I want to sort it to become, um, oh, so I want it to become legs. Um, and then, so if I wanted to do that, all I needed to do was to call on this collections interface. There's an interface called collection. We could see that. Let's say okay, let's go to list, and then this is the interface called collection. And you can see that it's extending this iterable class, which is this one you're seeing here, this guy you're seeing here. So it's extending it. So all of these things proceed from everything you're seeing under here are coming from this guy on top. So everything will be clearer in due time, sure. So if okay, back to our sorting. If I wanted to sort, all I needed to do was to do collection dot sort, and then we'll pass in our list that we want to sort. Let's say we want to sort this our list called R. So this is how we do the sorting. And then the other one if we want to sort, what are we sorting? STR. Can we sort LK? Yeah, so this basically is how we do the sorting. So the idea is that the code for sorting has been written once in the collections interface. And all these guys that are now under it, we just behave based on that one code that was written in the collection interface. So for this, okay, let's not keep deep in deep. So if you want to sort, this is how you do your sorting basically. So you call this interface, that's the collections, followed by the method sort. There are many other methods under collections. If you want to see more, just write collection dots and you see the suggestion that is giving you. We have add all, we have sort, we have empty list, and I think um, a number of other ones. A number of other ones. I've not even made use of up to more than half of these things. So you know that these things are existing. They're actually existing. So for the most part, what you'll be needing is to sort for sorting. So if I print this thing, if I had a list of this number and I do this thing, this is what becomes of that list. It sorts it into like this. Observe that this is not returning anything. Just by writing it like this, it has sorted this list. Now it's possible that you may want to. It's possible that you may want to keep the original list before sorting, even after sorting, basically. It's possible you want to keep that old list. So what you could do is to say array list. Let me comment on top. Let's say to keep old list. What you could do is to say array list, which is also in integer. We say unsorted. This is before sorting. Unsorted list with the new array list. And then what's the old list? So this is how you create a list out of an old one. Because if I don't do this, if I went ahead to sort, I'll lose this old one. And I'm telling you that it's possible there are cases where you need the old list in the order they exist. So first of all, you create a copy before you go ahead to do your sorting. So just by doing this, I'm having my old list, and then the sorted list. So this is the code that sorts it. Now if I print on my console, what's going to be on the console is going to be in this order. Okay, so this is it for sorting. This is it for sorting. I'll remove this thing. Any questions? So I want to go to the hash set. But any questions so far?
I think I do.
All right.
Because while I was doing my assignment, I wanted to do that sort,
All right.
and even it came up when you um I don't know, when you do collection dot sort, something comes up. No, like the Java tries to help you.
Autofill it.
Yes, I was thinking maybe I was even saying maybe I will ask you in class, like you will fill in. I don't know if you can help us. Just try to do the collections dots. It will come up before you finish.
Like, was it what I did before? Dot. What was that?
So I heard that lists.
This one.
What's the comparator? I
Which one? Which of it? Okay, comparator.
the, yes.
Oh, comparator. Comparator is okay. This is another interface of its own. It's another interface of its own. This is for, say, for example, you implemented another system of sorting. You don't want it to be in the natural order. Say, for example, okay, let's just do it. Let's use it.
Um,
So the default order of sorting is in ascending order. And what that means is from small to largest, which is this. Now, if I wanted to sort the other way around, what I could do is to pass that list I want to sort, and then pass in a comparator with which it will, like I said, if you don't want to use the natural order of sorting, the other thing we could do is to do collections, is to what? Pass in another system of sorting, which you have predefined by yourself. But if in this case, what you want is the one that goes in reverse order, you select collections or reverse order. So by doing this, after sorting, what it will give you instead will be 19, 10, and 3. Do you get?
okay.
Yeah. So basically, if you come here and do dot, it's asking you, where is it again? This is the first one because I used it last, it has come up. It's telling you that you have another way with which you want to implement your sorting, other than the default way, which is in ascending order. If you see, it's telling that the first parameter takes in the list you want to sort, and the second parameter is the manner in which you want to sort it. But if you don't pass in the second parameter, and if you leave it as empty, the method, the overloaded, always remember, the overloaded method that we then use is this other one. You can see that we did it here. If you pass in only one parameter, it will take it that what you want to do is the ascending order, the default one. But if you pass in a different way which you want to sort, it will then make use of that one. So let's say I want to sort collections dot reverse order. So, okay. So by doing this, it will sort in descending order. Is that fair?
Yes. Thank you.
Any other questions? Okay, so for hash set, so it's similar thing for set. The main difference between list and set is that set does what? It doesn't accept duplicate values. Let's say this is a set of, let's say double. Let me call it set equal to new. Always note that what you put on your right hand side is a class that implements that interface of set. What you put on the right side must always be a class. But on the left hand side, it can be a class or the interface. But if we use class, it's not the best practice for most of the cases. And you'd be advised to always use the interface to give us the ability to switch. If you look here, another one that is implementing set is the linked hash set. So this linked hash set, the difference between it and this normal set is that linked hash set uh, gives you a particular order. Say for example, if I have a list of numbers like this, say 2, 3, and 1. If I come tomorrow and I want to, if I come tomorrow and check this my set again, it could be of this arrangement 3, 1, 2. And if I come next tomorrow, it may be different thing. So with linked hash set, it gives us the ability to keep ordering. But for many times, you may not need the ordering. If you want ordering, you use your list. But if you want ordering with no duplicates, you use linked hash set. So the main thing about hash set is that it keeps ordering. Sorry, it removes duplicates. So if I try to add another number now, the set will not accept it. And because set is implementing the collection interface, most of those abilities you have in your list, you get them here. Most of those abilities you get them here. Now remember I said that because set doesn't okay, let's come in. Okay. Now because I remember I said because set doesn't keep ordering, and therefore it means that if you come and try to get the first element, the element in the first place, that's index 0, you're not guaranteed to be the same thing that was there yesterday. And because of that, set doesn't have the method that we can find in list called get. You can see there's no such method as get. Unlike this one, if I did str.get, it will ask me the index I want to get. So Java requires that you know the index of elements. You need to know the element that at that particular index you want to get. Or even if you don't know it, you should at least expect that something there is consistent, even if I come to check on it tomorrow. So if you need to implement such that the element here needs to be there tomorrow, you have to use list. And because we're not guaranteed of that kind of thing, uh, set doesn't implement it. There's no such thing as does get and set. But if you look, you can see other ones like you can play around with set. Set will give us the size of element that is there. Set gives us the ability to add elements into that set. And these other ones is empty, contains blah 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 blah. Then there's this other, okay, yeah. Basically, that's just it. So I'm not going to start going through all of this method now because it's similar to your assignment. So just for you to know all of the methods that exist and then how to play around with it. Any questions? guess we're fine. So the third one we're going to be dealing with is sorry. Okay, so map. All right. So map, map. Has anyone used JavaScript or Python before? JavaScript, Python. Any of us? Any of us?
Yes,
Anybody?
sir.
Ah, put it up. Put it up. Put it up. Who? Who spoke with it?
Yes, Jennifer. I said yes.
Okay, Adam.
Oh, it's Jennifer.
Okay. Do you remember that? Do you know the data structures that holds key and value pair?
So what did you say?
There's a data structure that holds key and value pair. Key and value. Key and value pair. Something like this. We have something on the left hand side, and then we have something on the right hand side. This kind of thing. Or does anyone have an idea? So in JavaScript, it's called object. In Python, it's called dictionary. In Java, this is called a map. So map gives you gives you the ability to have two values mapped to each other basically. So on the left hand side, we have the side that is called the key. On the right hand,
Sorry, sir.
yeah, come again.
Your voice is breaking. I can't really hear you.
Well, just okay. Just let me know if it's breaking. Is it better now? I can't do anything about it.
Yes, I can hear you now. The last thing I heard was you said, "Does anyone know
Okay.
the type of what?"
Okay, I was trying to introduce you guys to what's called map. Is the voice better now? Is the internet okay now?
Yes, sir, it is.
Okay, so I was trying to introduce you to what's called map. So map gives us the ability to have two values that are paired to each other. So on the left hand side, that's what's called the key. Then on the right hand side, we have what's called the value. So how map works is that you know how your dictionary works, like English dictionary. So you have a word, and by tracing the word in dictionary, what comes along with it, the meaning of the word. So it's just similar thing with map here. So by me, uh, so by me calling a value, by me looking up my dictionary and check what the key side is, what's paired to it is the value side. And how to implement map in Java, you can see already it's suggesting two things. You can see it's taking in two values, which is the key and the value. And how to do that is to specify the type of object that will be on the left hand side. Let's say, for example, now the kind of object to be, let's say it's character. And then on the right hand side, let's say it's what, let's say double. It, it can actually be any data type, any data type. So it can be the same data type on the left and the right hand side. It can be different as you can see here. And then you know how you do your how you create your new system. So you say new hash map. So HashMap is a class that implements map. Like before, I can just decide to change this into HashMap. But also like before, it's not advised to do that, although you can. So I could have my map on the left hand side, and then I'm implementing it in my HashMap. So I'm making a HashMap. So by just doing this, I've created my map or dictionary. And now, how do I fill up this? How do I fill up this my map? To do that, we specify map dots. You can see every object, every method that comes with this map, with this object called map. These are all of the methods that come with it. Everything you're seeing here comes with the object called map. So we have something like the entry set. We have something like put. We have something like values. We have something like put if absent. So with time, you'll be more acquainted to this. And something else I need to point out to you guys is the okay after try try and open a what's it called? What's it called? Code Wars account after now. Code Wars, Code Wars. So Code Wars is where you practice algorithms. For a back-end developer, algorithm is advised that you learn.
Did you say cold water?
Was I typed it out here? Code Wars.
Okay.
Yeah, just for you to flex your brain ability. And for you to it forces you to make use of all of these methods, and by making use of it you get acquainted to it. So if we want to our map is still empty at this point. We've only just created it in memory. So if we want to populate it, we make use of it. And because we told it that the key side will be character and the value side will be double, what you have to put to be of those types. Let's say I want to put what character I want to put. Let's say I want to put A, and on the value side I want to put 2.1. So this has been stored in this my map. I can also put more values to this thing. I can put more values, and it always has to be of the same type. Let's say two. And just like every other data, everything I've been speaking out since, list, map, blah blah blah, all of these things are considered data structures. Just so you know, if I've not mentioned it, are considered data structure in the sense that they give us the ability to arrange our objects or data in different manners, in different structures. So set gives us the ability to store unique elements. Collection list gives us the ability to store collection of items, repetitive or not. Sorry for the background noise. I'm actually at a place. What else? What else? So, is it too loud? I am not sure I can do anything about it now. But I guess you can hear me clearly.
Yes.
Okay, that's fine. So, for the most part, you can't just create an empty map and leave it. This put is what mostly make use of. So by doing this, I've populated my list, and if I check my listing, what I could, what my list is going to look like is something like this. A, sorry, A, then 2.1, 2.1, and the second part of it, uh, that's B, and 3.2. So this is what our list is going to, this is what our list is going to look like. Now this is how list works. This is how list work. I can't just magically get what on this on my value side. That's this 2.1 and 3.2. I can't magically get those values. So to get those values, think to yourself, how do you want to check? If for example, I check keyword in my dictionary and say keyword is let's say a handle that helps us build a good number of keys. To check it in my dictionary, I can't just go straight and check and pinpoint this definition I've just said. But what I could do is to check for the word keyword in dictionary. So if I want to get the value, say 2.1, what I could do is to do map dot get a, and what's being returned now is of type double. What's being returned is of type double. So if I wanted to store this thing, if I wanted to store it in a variable, let me call this d. This is how I would do that. So the value of my d now is going to be 2.1. So this is going to be the value of my d. Because I did a map, which is this map, dot get, what are we getting? So we're getting a. So to get the value side, we make use of the key side. Is that understood? Exactly.
Yes.
All right. Okay. What else? What else? What else? What else? Okay. There are a couple of things to know about map. Now, let me just type this out and see if it makes sense to any of you. If for example, I say map dot put a, and let's say this one is 10.0, 10.0, and and if for example in the future, okay, I've already as I've done now, as I've done now, as I've done map dot get what a, what do you think the value of d would be? Is there any guess? What would be the value of my d? I'm trying to get the value, the corresponding value of character a.
Okay, I think 2 point.
2 point what?
I think 2.1
Why can't it be 10.0?
because you already put 2.1 in place of 10.0.
In what?
I think you put 2.1 in place of 10.0.
But 10.0 is still here. The put is still here. Why wouldn't it be the value that it will bring out?
I'm not sure about the reason why.
Okay, so this is the thing. If you do such thing like this, the computer will be confused as to which one to bring, whether it's 10.0 or 2.1. So for that, there's a rule in HashMap that specifies that it accepts only, it doesn't accept duplicate keys. The last one you put will override any other one that has been there. For example, I had something like here. If I come here and say I had, let's say, 14.0. This particular one will override this one, and then this one, this last one, will override this other two. So anytime you put something, it will override any existing entry that has this particular key already. And if you look, IntelliJ is already suggesting to us a duplicate map key, and it's telling you that there's a duplicate map key, and therefore you should check for the one you need to use and remove the rest. But if you fail to remove, just know that it will override any old one and leave the last one for you as the value of our A. So if I printed this, it will not be 2.1, but instead it's going to be 14.0. All right. Blah, 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 blah. So one thing else you can do is to do map dot to get all the values of my, all the key side of my, because we know that map has only unique keys. It makes sense to say that it takes in only, let's say, it takes in only that is of type set basically. That's what I'm driving to. Since it doesn't allow duplicate keys, it makes sense to state that the key side is of type set. Maybe it can be considered as set. Let's say I wanted to get all the key sides. in my map, I could do, let's call it S. I could do map dot key set. So if I return this thing, what's going to be on my set is going to be A, A and B. Exactly. Exactly.
Yes, sir.
Okay. Okay. Um, so we could also do the same thing to get our values. So map dot values, and this is of type what? If we do map dot values, where is the values? This. You can see that it's returning a collection. So if I do this, let's see if it will accept list double. Okay, so it needs to be a collection. Okay, or you can cast it basically. You can cast it. If you remember what I told you guys about casting. Okay, but I won't talk of cast. I don't think I mentioned it though. But I won't talk of casting today. So collection of double. So with this, I'm having a list of all the values, all of my value side. These are a number of other things we can perform with our collection. So we can add to it. You can find the size. You can check, you can check if it contains a particular object. You can remove from it and other methods that are there. So one thing we could do to list through a map. So there's a unique way of looking through a map. There's a unique way of looking through a map, and that is by using entry set. Because let me remove this. I don't need this here. So because map has a character as well as sorry, a key as well as a value site. So to look through map, we'll do something like for map dot entry, and then specify what on the key side, which I know is of character, and the other side, which I know is of type double. Now this is another system of looping, and I'll not introduce it to you, but this is called the for each loop. For each loop. So I'll type it out and take my time to explain it one by one. So what's the name of our map? I would say map dot entry set. So um, so understand that this map dot entry set is giving us the ability to okay. It gives us the ability to get each key and value pair. In this case, A and 2.1. In the second case, um, 3.2, 3.2, B and 3.2 basically. So this is what each entry set is like. So we can have as many entry sets as possible. We can have as many entry sets as possible. Say we have another one called C, and let's say this is 6.0. So this is another entry set of its one. So this thing you're seeing here is like, for, remember I called it for each loop. So it's more like saying that for each of these things, this is considered as an entry set, and for each occasion it goes, it's considered as M. Each entry set is considered as M. So what we could do is to, for example, if I wanted to know what the key side, what's on the key side for each time it enters, what I could do is to m dot get, I believe it's get e, yeah. So get e, and I could also go ahead and print the value side, get value. So I could print to my system to know what each entry set is like. So for each time, for the first time, our key would be what A, and our value would be what 2.1, and the loop will be again. The second time, our key would be what B, and our value would be what 3.2, just like that, on and on. So to loop through HashMap, we make use of what's called this for each loop. It's similar to the normal way you know of looping. That's looping with I. That one you do I plus plus. You can also use this system of looping. That's the for each loop to loop to do the other looping. But for HashMap, this is how you do it. What more? What more? Is there any questions so far before I even proceed? Can't think of any other thing to say. Any other questions? Any questions? Yes, we are good to go. Yes, we are good to go.
Yeah.
Yeah, yeah, who is speaking?
Question from the side from Mexico.
Okay, okay. I guess that should be it for this night. My laptop is dying. All right. So I wanted to mention something. I can't think of it now. So two things you guys need to do is to open a Cold Wars account. Um, so do it this night actually. Do it this night. And just go through it. And has anyone made use of GitHub before?
I actually have a GitHub account, but I'm not pushing it into it
I don't hear you.
because
I can hear you.
I said I actually have a GitHub account. Can you hear me, sir?
Yes, I can hear you.
I actually have a GitHub account, but I have not pushed anything to it because of I'm actually not ready yet. So I'm just keeping it till like maybe when I'm done with the exam.
Okay, so the manner which we've been submitting our assignment is actually not the way a developer should be doing it. So I need you guys to start getting acquainted with GitHub. So GitHub is basically a platform where we share our code so other developers can access it. And majorly or mainly, GitHub is for versioning. That's for version control system. Is a version control system basically. You see the way our apps and applications and whatever they from time to time they do have different release of versions. Say version 1, version 2.0, iPhone 13. iPhone 13 didn't get to where it is without other previous versions. So it applies to our codes too. So GitHub is a place where we can keep track of all the versions that have existed in the past. So basically, the basic part of GitHub is what we'll be needing for the most part, and that's what you start making use of. Say from maybe next class Saturday to submit your or should I say next assignment to submit your assignments. Um, so I will drop a resource for you guys to learn GitHub. It's not written on the board in class, and if you have difficulties with it, quickly reach out. There's no point wasting time. So we reach out and then we try to solve the problem together. And so henceforth, no, not henceforth, probably our next assignment, you'll be submitting your tasks on GitHub. You're submitting your assignments on GitHub. So two things you need to know or you need to start working on now is code wars and GitHub. All right, all right, all right, all right, all right. I guess that counts. That should be it for this night. Today is Wednesday. I'll be dropping an assignment. So okay, good night. Good night, Jennifer. My voice is cracking. I'm actually done. Good night, guys. So I'll drop the assignment and we'll meet next on Saturday afternoon. Please try and be early on Saturday. Should be by 3:15, I guess. I'll be 3:30. 3:30, yeah. Are we fine to go?
Okay.
Hmm?
Thank you, sir.
Don't any of you attend weddings. I'll be none of your friends is wedding this year. I don't know if they happen. No as shall be amongst us. I be all of you don't marry finish. Okay, oh. So we meet on Saturday. Bye bye. Good night.
Okay, good night, sir.
Yeah, good night.